All right, so some high voltage testing. My power supply is going to turn off here once it gets up to the ZVS circuit turn on. There it turns off, and now we're going to come on. You can see our spikes. Zoom out. Yeah, look at all those harmonics that we get. Let's see, that spike there is reading 118 kV or kHz. That one there is at 38 kHz. That's our primary mode. If I switch over, turn this poor thing down, so we can zoom in and actually take a look at this waveform. You can see it does not look like a sharp triggering. It looks like a pretty smooth waveform, actually. You can see all those spurious ones everywhere else, but I think the FFT is probably the best way to go. Zoom back in. So here we can see like our last noticeable resonance there. I see one here, and then there's one or two past that. That one there's at 276. That one there is at 312 kHz. And it looks like there might be more, but real hard to see. I would think there'd be another one right there, but it's not steady. So I'm just going to say that 312 is our last one. So let's go through and document each of these resonances. See if we can't come up with some kind of equation form. First, actually, though, I want to zoom in all the way to the beginning here. That's 2.5 kHz per, that's 1.25 kHz per division. Let's see. So the first noticeable one there is about 2.3 kHz. We have another one at 4.55 kHz. And then this one's got some shoulders on it, but the main is at 6.85 kHz. There's another one that's real skinny right there at 9.2 kHz. Let's zoom back out here. Next one, and that one looks really strong, is at 11.5 kHz. Oops, wait. But that 11.5 kHz down, where is that at? That was down here somewhere. This is really more 16, 23. First one there, those two are right next to each other. That's 29.8 to 30. Next one's at 32. But here's the main one that my multimeter registers, which is at 39. My multimeter actually registers that at like 39.4. But now watch this. As I adjust my input voltage, it's going to change the timing. I don't want to turn it up too much because I'm kind of scared of burning out the oscope, but hear the sound of the fan in the background of the ZVS driver board. It kind of looks like as these two come together, that's probably a sweet spot there. Let's move this cursor off. Let's see how our main spike changes. This isn't almost exactly 1-for-1, but, or should I say 1,000-to-1, but it's relatively close. I want to say like either 15 volts on this equals like 17 or 18 kV. I normally get it up around up to 20 on here, which is like 25 kV. You can see I can actually turn it up too much and get those two swap past. I kind of want to zoom in on that. Let us zoom. Let us see what happens. So if I had to guess, it'd probably be around there, which is 15.1 input volts. Let's zoom back out. Let's zoom in on our main spike. There we go. Cursor. So right here, now we can see that we're actually sitting right around anywhere from 38.9 across the whole top to 39. You can see how that'll move quite a lot though as you change the input voltage. So now let's just compare that, because as we could see, the actual waveform was not super helpful. Although while I got it connected, how about I do that? I will alter the input voltage while we watch the waveform. Wrong way. There we go. I want RMS, but yeah, let's look at some rise times. Come on. There you go. That rise time really jumps around a lot. So we're at 25.6-ish. It stays pretty steady. All right. Last thing to show is on this guy, this little $20, $30 multimeter. You're able to see the frequency on here. Alright, so start off with the voltage. Gotta be careful holding this thing because it will zap me. Alright, so Right now you can see, wow, according to this we're jumping all over the place. But it's 1,000 to 1 high voltage probe. So when it says 25 on here, that's 25,000 volts at 10 volt input. That's crazy. Let's see, so when I get it up to 20, it may shock me. There you go, so that's 43,000 volts at 20. Yeah, I'm gonna keep this bad Mamma Gemma way down here. According to Alexi, we only need 20 kV input, which ballpark is going to be around 8.8, 8.9 volts input. Anyways, I can switch on here to frequency. You can see that it says it's at 39.06, so this actually has better resolution than my Tektronix, go figure. But as I adjust this input voltage, you can see what that does to the frequency. It does bring it down, but very, very slowly. Right. So at the 8.8, 8.9 that we said we need for 20 kV, we're at 3960-ish. Yeah. Oh, and the waveform you see, this is oscilloscope is not connected at the moment. Just hanging leads, but the leads hanging over the case, it's enough for it to actually register.